Hello again. I'll continue my journey with Mule ESP here by describing to you a little information about the cache scope that you can use to write cache functionality. Let's start by creating a new Mule project as usual. We'll call it cache test. How unique. We can start by setting up a simple mock flow that will be our final endpoint. Let's put a payload inside the end flow. So this will just act as a web service. We will create the basic connector. We will listen to port 881 and everything else can be just as normal. We will allow get methods and let's call this resource. Be our resource that we're going to call. We can just quickly set the payload here too to my data. So that's basically how simple you can deploy a mock service or a test service that you can use in your development work. So we will just hit the web browser and we'll try our service and resource, and it just returns my data. It's exactly as we intended. So, what will we do next? Yep. Let's create a new flow, and this will also be a HTTP listener. And we'll call it cache, and we'll allow it to get, and we'll use the same HTTP connector as before. We will set up a cache scope within this, and inside this scope, let's put a logger just to see that we're in the cache scope. We can call, and also let's put a HTTP outbound in here to call a web service. We'll add a default connector to this. We will call the resource path by get, and we go to the advanced, add localhost, and port 8081. So this is very simple, and by just saving it, it will automatically redeploy itself. And we can also do a quick check in here. We can see this clearly containing all the values that we've set. In this view, you will have to double click, check each of these tabs, find the values that have been set. But I like this view more. You can just glance it here, and you can see that you got your listener. It's on the cache. It allows get calls. The path can probably contain / that doesn't really matter. And we do have our cache. It's not containing a strategy. Perhaps we should add that. Let's just go to the cache here. We will reference a caching strategy that will be created by ourselves. The object store should be a in-memory store, of course. And let's use a custom key expression here, just to build something from the URI that is being executed on this HTTP endpoint, just so we can separate a call that should be cached because it has already been done, and a cache that should. So let's just real quick get this. We'll use the inbound property. Oops. So old. Just use double click properties, and we will use http dot query dot string there, and hit OK. Let's deploy that. And now we will return to the browser window. Let's call the cache application and send a 1 insert. We can see that we're in the cache scope and we're making the call. Let's call again. And we are still in the cache scope. So our cache is not kicking in right now. Let's find out why. So we are having our object cache, our object store caching strategy. It's referencing the query string, and we are using a unique query string. We have a in-memory store, and we call this the caching strategy. We reference that caching strategy in our cache. Inside the cache, we are doing a logger, and we are making a request. Because the MuleDSP is such a clever tool, I assume that it is thinking that this isn't really a static content, so we should probably not cache this at all. So let's just change the payload here to make sure that we don't get any magic headers from the HTTP request. So we'll just add a new data and then hit save and check it deploy itself in console. So now we'll start again. Let's hit this once and we get a buffer input stream. Of course we do. We will need to transform this. So let's transform it by an object to stream transformer. Object to string, and we'll place it first there. Hit save. Watch it redeploy itself once more. And now we will run it. We can see our cache data. We'll run it again. And if you look down here in the log, nothing is happening now. I keep updating this. I'm updating it. What I call. If I change the URI, remember we used the URI as the key for the cache to recognize if this is a unique call or not. And look down there. It's making the call once more. So we'll keep clicking here, and we hit the cache. We hit the cache, and we hit the cache again. So once you make a call which doesn't match the criteria for the key, meaning the query string we sent in, it will make the call to the outbound endpoint, and once it hits this row, so it returns a payload, it will inside the in-memory store store that key together with the returning payload. And next time you enter the cache, it will see, I already have that key, I will return that payload. So it's a clever solution. It's probably not something you'll use exactly like this, but you could use it in various scopes just to optimize code that otherwise would mean that it makes lots of calls to outbound services that might not be necessary because it has already done it with those services. If you're processing orders with with customers, where each customer normally makes a lot of orders, and you will need to do a lookup on the SSM or something. You could put that lookup inside one of these caches. So the first time you're sending the SSM, you get back your customer detail. It will access your database or web service or wherever you're picking it up from. And the next time, it enters that very same cache flow and finds a hit for the SSM, which you can use as the key in that case, and won't call the service, but will instead fetch the data from the in-memory store and return it. So that's a quick browse of the cache scope. Hope you enjoyed it. See you again soon. Thanks.